Hey,
Good afternoon, Chief. How are you doing today?
I'm good, thank you.
Good, good. Thank you for agreeing to this interview.
hmm
We're excited to hear your expertise with aircraft generation with regards to risk management practices.
Okay.
Just to start off, could you tell us a little bit about yourself and your experience in that department?
Yeah, absolutely. Chief Master Sergeant Bill Hensley. Been aircraft maintenance for 28 years of my career in the Air Force. Roughly 19 different types of airframes to include from fixed wings to rotary wings to bombers to fighters to, heavies. I've covered pretty much every gamut, both nuclear side and conventional side generation, deployed ATO generation. So lots of experience in doing that. Currently, I serve as the WSSG group chief here, so it gives me a perspective of a lot of things that I've done in my career to be able to apply those in a unique situation that doesn't necessarily mean a maintenance chief gets to use. So it's a good experience.
Sounds like you have an incredible breadth of experience. So I'm very excited to hear your perspective on some of these questions.
hmm
So if you don't mind, we can go ahead and dive
Sure,
in.
absolutely.
So first question is, what experience with Air Force risk management do you have?
Well, I think a lot of it, I think the Air Force has called it a lot of different things, right? We've called it ORM, we've called it common sense at certain occasions, but we've always talked about like understanding that what we do is inherently risky. Like everything we do, to say that you're going to do a job that doesn't inherent risk, it's just not possible what we do. You put a situation of just when you're doing it a home generated airplane, slow down in a combat situation where there's much more pressure. I think ORM was the one I always took the most from it because it was a applicable look at like what you were doing, and you assumed the risk, but was the benefit worth it? And in certain situations we would assume risk, specifically in a deployed location, that we would not necessarily do in a conventional, correct, right, in a stateside type of AOR. But ORM to me has always been the best. It's the one I always try to preach. So,
Copy. Can you describe what systems the Air Force is currently using to apply risk management with aircraft practices?
well, currently we do. You do. It's really weird how the Air Force has changed on us. It used to be very intense. It used to be very scenario based. Like you were put in situations that were high tense. Here's a perfect example. Um, when we used to do what's called ORIs, operational readiness inspections, like we would do aircraft maintenance in chem gear. Like that was a risk that you had to assume, right? Because there was a time where depending on where you were, that was a known threat that you'd have to deal with. Honestly, the Air Force, I see them talk about it, but program wise, I haven't seen much as far as like, hey, they've got a deliberate process. I will say the chief of staff put out a conversation about risk management across the Air Force and had brought in some different situations. I think really trying to highlight the idea that we've kind of lost focus on it, and it's something that we probably should go back and start looking at again. Because inherently, last year I think last year was one of the largest years we ever lost, like total loss of aircraft that was based on human error. So it was a really another focus back to start having those conversations, and it was really focused on the idea that, as I said, aircraft maintenance is inherently risky, and first of all, making decisions at that risk at the right level. Like, are you able to assume that risk? And if you aren't, what steps are to mitigate that, and who do you bring into that conversation?
So this next one is probably good with the lens of refocusing our risk management
hmm
practices. How do you see AI and innovation increasing safety in aviation risk management?
Um, I see AI. So you see a lot of virtual as far as using AI for scenario-driven situations, right? Um, I think risk is always going to be inherent, as I've said before, and not to beat that horse. But the idea is the way to mitigate that is proficiency, and a lot of times our training programs used to be very much based on that. You had CDCs, you had so long you had to be proficient in training. You did OJT, right? Your qualifications, your CFTPs. We went away from that. We went to like we're going to do real time training, right? And what that has basically created, and I'll get to the AI thing here, why I think we're really going back to it. But what we lost was the idea that um, we were very deliberate in that training, even though it was very basic. But if I got like a 5 level, for example, maintainer hydraulic systems, I knew what his qualifications were because I knew he had had a baseline CDCs, he'd been through tech school, he'd been through all these things, and I knew what I was going to get. Now, proficiency was always a little different, but the idea of understanding and knowing what I got. Now, if I get a 5 level hydraulics troop, depending on where he's at, like what base he's come from or what experiences are, it could be anywhere from somebody who has really very little capability to somebody who's worked a flight line on a fighter like constantly. It's become so widespread. Now, what has the Air Force done to fix that? AI has become a big part of that. You see, everybody's spending, like the Air Force focused a lot on virtual imaging, right? The headsets and the training, and the idea is to build that proficiency and to try to build some scenarios from that perspective. I think in the end, when it comes down to, it's just going to be simple training. Like, there's no easy way to say, hey, we're going to get past like overcoming these issues. Incidents are going to happen, but I mean, training based on proficiency is always going to be extremely important. And the AI part, they are, and the technology in general, I'm hoping is going to bring us into a new fold of what that looks like. So we're able to mitigate those risks, have that proficiency, better trained technicians, and stuff like that. That's what I really hope that brings forward for us.
Okay, that's a very interesting perspective. Thank you. So I know you mentioned human error is kind of the crux of the risk management conversation in the Air Force. Do you think, with regards to training, AI has the potential to help with the most, or do you think that AI would more apply to like looking at lagging and leading indicators or cross tells or things of that nature?
Well, I mean, the AI part, I think AI part is going to suffice on the idea of a proficiency-based training. Like, it's going to be able to try to mitigate some of those things. Inherently, some of the things we're dealing with and some of the things I talked about, like the risks that have happened, it's a cultural change. Like, the Air Force has changed in a perspective from the days when I was a technician, like a driving technician, where like, it was like, you were very focused, you followed that teal, you were very mindful of that. We also built people how to be troubleshooters. Like, if you know anything about the Air Force, there are no 7-level schools at all anymore. Like, very few, I should say. But like CDCs are pretty much gone. So we've really pulled ourselves away from that. Where, I'll be honest with you, when I learned the most about being a good technician was at 7-level school. Yes, it was fun, and there's some niceties come with that. But like, really to be able to shoot wire diagrams and be able to do some of the things, I learned so much based on that. So the AI part, I mean, I think we're doing great parts. The biggest issue we run into is just the overall cost. And the cost is pretty substantial. I know for the J models they were bringing on, it spent well over $500,000 on just because Lockheed Martin was building the AI training programs. And those programs aren't built, so you have to go to them and they will actually generate it. So, you know, will that address the issue as far as overall like risk management? I think it's a part of it. I don't think it gets to all of it. I think culturally, a well-rounded technician with the right mindset will always be the number one factor that has to be there. Training is a huge part of that, but that right mindset, understand that risk that you're taking, is going to be extremely important.
Okay, that makes sense. So currently, can you describe the predictive maintenance tools that the Air Force uses for mishap prevention?
Well, I mean, we do two things. I mean, and that's really a lagging indicator, right? In a sense, as we each year we look at how many accidents we had, and then we talk about, oh, this year we had a high year in FOD. So then what do we do the next year? We focus on FOD, or we're always seeming to be behind the curve, and as far as like the things that we need to do to be able to be predictive at that. Honestly, I think you start with the idea of setting the right principles, setting the right training, and then holding an accountability as far as how things should be done. And in the end, your lagging indicators are going to tell you whether your focus was right or wrong. We can't be reactive in this, and that's what I almost feel like we've become. You know, we're coming out of 20 plus years of war where everything was reactive and everything was about doing one thing, generating airplanes at all costs. And as we were transitioning out of that, we've got to go back to a lot of the basics that really, like when I came in the mid 90s, was huge. Like, that's how I learned to be a technician. So that foundation is what made it better when I was put in a situation where I was in a combat situation generating airplanes. Like, you go back to, it's like riding a bike. You just go back to what you know, and you have to have that foundation for perspective. So, but it's hard to say that we have tools. Like, we talk about things, and I think we have the underlying conversation we always talk about. Tool management, you know, PPE. We talk about all those things, but it seems more like it's like not as focused on like as it should be per se.
Like more lip service than
it is.
Actual training.
Mm-hmm. Because then we get to the end of the year and then we realize, hey, we had this huge amount of FOD damage. We talk about FOD all the time. Why do we have to get to the end of the year to make at that point? Now we're going to focus on it. So I think a lot of it as far as preventive is just, first of all, doing what we say we're going to do. So we're going to talk about, we're going to enforce these standards, enforce them.
Makes sense. So for our existing systems,
Mm-hmm.
for how we track our maintenance and how we kind of tie our risk management into that, do you foresee AI being tied into those existing systems, or do we not really have the infrastructure for that?
So you're talking about the biggest problem I'm seeing we're dealing with. We have multiple systems that we gain information. Like our MIS systems are not really the same. You had IMDS, Geo81. You had Allison. You had all these different systems. And as we've talked about multiple times, like every time we buy a platform, we buy another system that's not redundant to any other system, right? I think for us to actually be able to work through that and try to understand that and use that, we're going to have to find a system in which we have the same information goes in, the same information comes out for all platforms, right? And you talk about that. The biggest issue you have with airframes is interoperability of operation systems. We can take a weapon on one, but we can't put it on another one because operating system's different, right? The Air Force has been great at buying pretty shiny toys, but we've never thought about the integration part. Like, hey, why don't we have same operating systems between F-35 and F-22? Well, they're, same vendor. Why can't we? But we don't, because it's all about money. And when it comes to money, I hate to say it, unfortunately, unless we start putting that into the program part, we're not going to get there. And every time we come up, the system is always supposed to be better in how we get there, right? So I think starting with how we're going to do that, we have to find a common system. We have to, because because each system has its own things. Like IMDS was great at pulling some things. Geo81 is great at pulling some things. Every one of these systems has their pauses, but none of them are usually the same. So one's good for one and one's good for the other. And as we transition from IMDS, especially for like DPAS and stuff like that for equipment, it's going to even change more. And DPAS has already identified multiple LIMFACs. So it's hard. I think I love AI from the idea that you should be able to take that data and do predictive modeling, right?
Absolutely.
AI allows you to do things at a speed that the human brain cannot do. Like that's the positive of AI. Like taking mass amounts of data, which by the way, we have squandered tons of it over the years, taking that data and actually be able to do a predictive model for a life cycle of an aircraft, especially because in fact, most of our aircraft are beyond the cycles. Like we don't know what it looks like. We got B-52s flying and we're supposed to be done 30 years ago, but we're still flying them. And what we learn is the aircraft, as they roll out, the life cycles for the aircraft might be 30 years. We know predictively what the model is going to be for failure during that 30 years, but we don't know what the 30 years beyond that looks like. Things that are breaking that we never even thought about. And again, then it's money about programming and stuff like that. So, I mean, I think AI is great for the data and taking that and be able to do that predictive modeling. From a risk thing, I think it would be hard because I think as our programs change and our focus changes and like from combat operations to non-contingency operations, that you're throwing another variable in there that makes it very hard to be consistent to say, hey, this is what I predict every single time, because you're throwing so much different variable there. I think if you did 20 years of war and like you wanted to look at that modeling, you could do that. Now, as we transition out of, for example, Iraq and Afghanistan, and we're not doing that anymore, we're not generating airplanes that much anymore out there. So that idea of an ATO generation based on combat ops, it's not there. So it makes it a little bit hard. But I think AI gives you an amazing tool to be able to look at a huge, like factors that like for us as human beings really struggle to see and actually good at predictive model.
Okay. This next question, I think we kind of covered that in the previous question,
Okay.
but you already kind of spoke to this, the challenges with integrating these types of technologies into what we already have.
Yeah, it's just consistency and interoperability, like with everything. And I don't know if we're going to get that right until we finally start saying this is the standard, this is what we expect. I don't know if we'll do that. I hope we do. I hope for the future going forward, because it would save a lot of time. If you had the same exact operating system on every single fighter, it would be much easier to troubleshoot the avionics system on almost any aircraft. We could then have one type of avionics troop, not 4 or 5 for each different individual platform. That's just, those are the things I see that I think in the end makes it right. And the reason why I know it's possible, perfect example of the F-35, Israel rolled in and said they want their operating system on the aircraft. And firstly, Lockheed Martin's like, no. Well, guess what happened? They put that operating system. That F-35 operating system is interoperable with every single operating system of every single Israeli aircraft.
Wow.
Yeah, it shows you it's possible, just makes the contractor do it. And with that, their technicians, they have less technicians, they need to work different scenarios.
So they are essentially doing more with less, but
Absolutely.
with some better planning in
Yeah.
place.
I think they call them the F-35 IADS. It's IA. I think it's IADS. It's a variation, but that's a perfect example. And I remember reading that it was story I was reading about just in general about operating systems, and it specifically talked about that Israel demanded that they get that up because that brings them into an integration with every single weapon system they have, so they don't have to buy specific weapons. Like everything's integrated to each aircraft.
It's fascinating to think that what that might entail for the U.S. Air Force.
Yes.
So this next one, I'm just going to provide a little bit of anecdotal backstory to this before I ask the question. So my husband, his good friend, is an engineer for Bell Boeing.
Mm-hmm.
Right now they're developing a technology to basically look at several key bearings on the aircraft and have AI predict like, hey, you guys, this is about to fail, you need to change it right now. So do you think a technology like that would be useful for U.S. Air Force applications?
We're using it.
We're using it already.
It's called Infoqua.
Oh.
Here's a perfect example. Lockheed Martin, the C-130. So an aircraft in the past used to have so many flying hours or so many, basically either flying hours or let's see, it's flying hours or just airframe hours, and however you want to look at it. So that includes ground run time. The Infoqua system takes an aircraft, takes the condition in which it flies under, it's Infoqua.
Sorry.
No, you're good. And it takes the conditions of the aircraft, and then it tells you predictively that, for example, that this flight control actuator in normal circumstances would go 1,000 hours. But then you start getting a report that starts decreasing that based on how the aircraft is flown. So we have technology that's already being used. It's individual by certain platforms but Infoqua is becoming across the Air Force, is becoming a predictive measure to be able to predict failure of parts prior to like certain different life cycles.
That's fascinating because my only airframe, the CV-22, did not have that.
It has lots of issues though. No, I'm
it's got
joking.
plenty of issues.
No, I'm joking. But I mean, you can see that we're trying to change how we do things. Not only for like a maintenance predictive model, but like what's the number one reason that drives us? Funding, right? We don't have enough money to buy the parts we need to buy. Every year we set aside a certain amount of money to meet what we predict is going to fail. And every year on certain airframes we miss it completely. Like some things just fail out of cycle. And I think the Invoker program is a step to try to get us there and try to understand that and just be better predictors and take better care of our resources.
Is it safe to say that Infoqua will become you think it will become the standard in the future for our aircraft?
Well, I know they're using it. There's a system tied together, and I apologize, I don't remember. But Infoqua there's a predictive model system in which there's parts that normally don't have life cycles that are added as life cycle items. And for the life of me, I can't remember what it is. When I was on the 130, we talked about it, and they were slowly adding parts to that. And it was all based on the Infoqua data, how the aircraft was flown, and then the engineer's recommendations.
That is fascinating. I had no idea.
Yeah, because now we're actually putting a variable into the failure of parts that was never considered. Like, how's the aircraft flown? Because, for example, combat landings on a 130 is a lot different than doing touch and goes at Little Rock. Like, that all plays predictive measures of how the aircraft's going to react and really how long it's going to last.
That makes perfect sense.
Mm-hmm.
That's really cool. So, this is a good. I feel like this is a great question for an experienced chief. So, how do you think we should need to balance the need for innovation with keeping those strict safety standards up to par?
Well, I mean, it's hard, right? I think innovation will always drive, but sometimes I think innovation drives you beyond the point. Like, it seems like we always try to add an easy button to everything. And I'm not saying that makes it less safe or more safe, but I think what it does, it takes things out of like commonality, like doing certain processes. Here's a perfect example. The idea of bringing innovation for a tow vehicle, an automated tow vehicle that will pull up to an airplane and drive itself to a parking spot. Well, that works great until you like have to like do it in a combat situation or somewhere where you got to do it, and then you hit a light pole or you hit a building or you do something because it's not. So I think innovation is a great step to like, it's like technology in general. It does a lot of things to help us, but for some reason it seems to end up hindering us because there's certain basic skills that we lose, and we lose that muscle memory, right? And here's the funny part. One thing about the Air Force, about 3 to 5 years, you lose that experience. If you were to roll something in 3 to 5 years, that's 3 to 5 years you lose in development, because it takes about 3 years to get a solid technician in most career fields. That's why first-term airmen, when they get out and you get a brand new airman, you're starting over. That's a capability lost because there's no easy button to get that 4-year mark. So innovation is great in the sense that it's going to help us in a lot of ways, and I think it tries to address the manning shortfall, but sometimes you still have to go back to just having manning shortfall. It's like trying to do math with a calculator. When your calculator dies, all of a sudden you can't do long division. Like, You get what I'm saying?
I get
I mean, it's a basic thing that we learn, but we lose if we don't do it. And if you go generations, for example, and you don't do it, like you lose a calculator, you don't know how to do divide, you're like, I don't know.
That is true. Like in our critical line of work,
Mm-hmm.
like innovation is a wonderful thing.
Yes.
But sometimes, a lot of times, it seems to tip us over the point where it becomes adverse to risk management.
It does. Yeah, no, I agree with that. That's an actual great point. And then you have to throw somebody back in that situation, and then all of a sudden something happens because of lack of proficiency, lack of experience. And yes, it's there to help us, but when you have to go back and do it, for example, a manual way, then all of a sudden you have somebody who gets injured, or if something happens, it's catastrophic.
So it's almost like being choosy with what we want to innovate with is a form of risk management for the Air Force.
Yes. And really, honestly, I mean, I think, and you always hear the Air Force will try to stay. If we're going to innovate, we're going to go down that path. I think there's some real benefits to still being able to keep that basic muscle memory. Like if we're going to go to automated towing, we should still have a towing requirement to train people on it. There should be a proficiency requirement that ever so often we're going to do that. It happens. And the reason why we do that is those shiny toys break all the time. You're going to tell me because we can't automatically move an airplane that I can't tow an airplane? I'm going to look at you and laugh and say, grab a chalk walker and grab me a driver and we're going to go tow an airplane. That's how it works. That's how we've done it for years. But you'd be surprised. 3 years of innovation, we'll totally forget that we even know what an airplane looks like and how to tow it. So I think innovation is great, but again, I think it brings on its own risks.
That makes complete sense.
You know?
And I agree. We've all seen the good idea ferry more than a couple of times, I'm sure.
Remember, aircraft maintenance is still manual. There's no way to automate yourself to fix an airplane. Like going out and changing an actuator still requires just pure brute power. Just go out and change a part. It doesn't just click a button on AI and it doesn't happen. So.
All right, and our last question is, so this kind of goes back to what we were talking about, training, being the crux of everything.
Mm-hmm.
So what kind of upskilling or training do you believe airmen would need in order to leverage any type of predictive maintenance systems or AI assistance in their normal line of work?
Well, when you say airmen, I think if we're talking about tier one airmen, like airmen, I think that becomes a very hard part because at that point, you have airmen who are just trying to learn how to maintain airplanes and they're just learning how to do their job. If you're going to push AI and you start looking to some type of predictive maintenance, I would say you're probably looking at more to the tech sergeant to young master sergeant range, because at that point there's experiences they're going to get to that point. I'm not saying that a young airman would not be able to use that per se, but I think there would be some inefficiencies and based on some experience that AI would give you some tools to understand that you would probably see based on experience, you would see differently than somebody that was not. I think you see that in general when you look at aircraft maintenance, when you look at experience levels now, let alone bringing AI in there. I mean, most of our airplanes predictively tell us what supposedly is wrong with it lands. Do you know how often they're right? Not often. And I was in the B2 for a long time, and they talk about all the time, oh, you click this little button, tells you what's wrong. Well, it's funny because that number that's there might tell you what is part of the flag, but then you have to peel the entire system back to understand that these three other things may be causing that fault, and it makes you a better technician. AI is good for predicting and like stuff like that. Now, if it gets better, like it becomes more logical in the idea that it starts understanding patterns like aircraft failure rates, I think it's going to help. Like 9 times out of 10, when this part fails for this, it's this. And you could bring a young airman in there and put them in that situation and become a much more effective troubleshooter. But you're still going to be missing, because that 10th time that's not there, you're going to need that experienced technician to troubleshoot. You're going to have to do that. And that is something that a brand new airman is going to struggle with because they may lack that 5 or 6 years of experience. AI can give you a general idea, but it can't give you that experience. That's really the part that's going to be missing.
That makes sense. Like, AI is a very useful tool, but if you don't have the skill set on which to base it, it's, I don't want to say useless, but...
No, remember, it's all based on data. AI takes data and does a predictive modeling. Like, it gives you what's most likely is the most likely situation, right? It's a combination of all those things that you get there. If you don't understand, like I said in that 10th thing, that's why you'll see when aircraft goes down sometimes, you will bring an experienced technician there, and that person will be dedicated just to that airplane. Because he might or she might be the only one who has that knowledge, who's worked that system to be able to tear it apart and understand, the finer points that could be wrong. Not just change this box, but maybe there's 6 wires that come to this box that most people wouldn't think about, right? And how to dissect that system. Like I said, AI from that predictive, I love it. I mean, I'm fascinated by it. I'm also a little worried that we're taking a step further away from the idea of like being aircraft maintainers. Because when all hell breaks loose and you have to fix the airplane, you still have to be a technician.
Chief Hensley, thank you so much for your expertise and your insight into this fascinating and very new topic.
It is. No, I mean, and I think it's awesome. And being from the early days of coming in, I appreciate we're looking to do it better, and I always do. But I always go back to the simple thing is it still takes a maintainer and a technician to go out there and do the job. And without some of the basic fundamental skills, no matter how good your technology or AI is, you're going to be lacking if you don't build that foundational. So, I mean, I love it because I think it's the way of the future, but I also see some sides that if we don't address, we're going to create bigger issues.